How do we represent motion that changes? Alright, here's the objectives we're going to be going through with this lesson. We need to be able to change a qualitative position versus time graph into a qualitative velocity versus time graph, and vice versa. And we're going to be able to change a qualitative velocity versus time graph into a qualitative acceleration versus time graph. Acceleration versus time graph, that's a new one. We will be able to change a quantitative position versus time graph into a quantitative velocity versus time graph, and vice versa, and be able to change a quantitative velocity versus time graph into a quantitative acceleration versus time graph. There's some textbook reading pages, though I don't know that I recommend those officially. Motivation, here's our table of contents coming up. Vocabulary preview. As always, don't just watch vocabulary preview and think you understand everything in the lesson. Qualitative, qualified, described by words. Quantitative, adjective for something that is quantified, quantity, described by numbers. Value of a graph, how high or low a point on the graph is. Slope of a graph is how steep a graph's line or curve is at a single point. A tangent line is a line that just barely touches a graph's curve at one point but does not cross over to the other side of the curve. And an area graph, the area bounded by the graph itself, its horizontal axis, and two vertical lines representing start and end times. Get it? On the other hand, if you're not in calculus, this will be very valuable in physics, but also in future math classes. Everything we're talking about relates to how we communicate motion. We represent motion different ways, so we can communicate how an object moves to ourselves and others. Some representations allow us to make predictions, as we've done in the past. So we become these all-knowing beings who can predict what's going to happen in the future. Each representation has its strengths and weaknesses, so it is important to be able to work with all representations and be able to change from one into another. So that's like going from the data table into a position versus time graph, or position versus time graph into a velocity versus time graph. It's just having this fluid motion in between these different representations. Or maybe going from a velocity versus time graph into a motion diagram. Motion diagrams are good, but we don't know what's happening in between the dots. A graph is made from lab data also has this problem. The graph shows the same motion as the motion diagram on the previous slide. That small space, bigger space, it's accelerating, so our position versus time graph is concave up. Where is the object at t equals 5 seconds? We don't know. Probably right here, but we don't know. The motion diagram and the graph have the same problem. They are discrete. That means they only show isolated instants of times. This discrete word just means separated. So we don't need discrete, we need something continuous, which gives us all the information at all instants of time. This is a continuous graph showing positions at all the times. It is the best fit curve on the data, and a lot of us already naturally put in our best fit curve, or best fit line. Where's the object at 5 seconds? There we go, now we know for sure, by having that best fit data. Best fit line. Next lesson, we're going to use equations to represent motion. The best fit curve has the equation x equals 0.25 t squared plus 2. Looking at that, you may be able to understand where that equation came from. If not, here we go. By using this equation, we can plug in the time at 5 seconds and then solve. So it's so much more precise. To change a position versus time graph into a velocity versus time graph, remember the slope of a position graph is velocity. I feel like I've said that before. If the slope of a position versus time becomes more positive, the velocity becomes more positive. If the slope of a position versus time becomes more negative, then the velocity becomes more negative. If the slope of a position versus time graph goes towards zero, velocity goes towards zero. First example. Next video.